Hello, I'm Beth Eversole with SAS, and I'm going to give you an example use case for using SAS computer vision. The example I'm going to run through is perimeter security. And with SAS, you can combine image processing along with our advanced deep learning to address business problems such as perimeter security. Illustrating this, I'm going to talk about fences around pools. You may not realize that there are about 370,000 drowning deaths a year worldwide, and it's the third leading cause of unintentional injury death. And in the U.S., almost a third of those unintentional deaths in children aged 1 to 4 are drownings. These commonly occur in home swimming pools. Another great thing to know is that a 4-sided isolation fence that separates the pool area from the house and the yard reduces a child's risk of drowning 83%. Let me tell you a little personal story. This is a picture of my brother and sister when I'm one of 9 kids, and these are the youngest 2. My brother is about 3, a little over 3 here. My sister's about 2. And you know, when kids are toddlers, they're mobile, they can walk, and they're very inquisitive. And something can happen in the blink of an eye. And you see here they're getting into the cupboards underneath the sink. And luckily, smart parents are not putting any, bleach or toxins under the sink. In our case, it was just toilet paper so they can make a mess, but nothing dangerous. But I'll tell you a little story about my brother, Michael. He was not yet 3-year-olds when we were visiting some family friends who had a swimming pool. And he was on one of those little floaty toys and these rings like with a duck head. And unfortunately, these provide a false sense of security for the parents. So my stepmother was literally less than 10 feet away from him, sitting on the side of the pool, holding my little sister who was a baby. I was down at the deep end of the pool and I was diving, and you know how I was about 17 at the time. And, kids like to dive and dive. And then I came back to the shallow end and I looked around and I saw there was a kid underneath the water. I thought, well, this must be the little girl who lives here because she can swim. And then I saw her up on the deck, and I realized it was my little brother. He had slipped out from the inner tube under the water. I grabbed him. His lips were blue, his eyes were bug-eyed, his teeth were clenched, and he wasn't breathing. So I'm screaming, my stepmother screams, my dad comes running down. And the good news is that my dad knew how to do CPR and he was able to revive my little brother. So there's a happy ending, and this is my niece and some of my cousins. And in our family now, I'm very adamant, if you can't swim, put on a PFD. So I'm a big fan of that. But back to, how can we prevent drowning? There are 3 ways. There's adult supervision, but it's easy to get distracted, as I mentioned, and beware of false senses of security with floaty toys. You can have barriers. Fences are very important to prevent drowning. And of course, classes, training, teaching kids how to swim. So how does this relate to image processing? Well, one thing that you can do is use image processing to see where there are fences. In many areas, fences are required around pools. Public pools, private pools must have a fence around them in many places. So you can look at aerial views to see if you have these fences. That's one way. And this is not just an issue for swimming pools. What else needs barriers or one of the other ABCs to prevent accidents? So, for example, electric transformers, oil rigs, dams. These are all places that are unsafe for kids or teenagers. And they also could be targets of bad actors. So these need to be protected, or people need to be protected from them. Back to my ABCs, with just A and B, we can build barriers, but they don't always work. Kids can sometimes climb over them or tunnel under them. We can also add adult supervision by means of video. So you can have video cameras, and you can have people watching those video cameras. But what if somebody gets, a text from their wife saying, please pick up eggs or something like that, and they get distracted and they don't notice, the security guard doesn't notice someone entering an area? Well, how about if we use SAS, computer vision, combined with deep learning to send alerts? So in order to have alerts, the computer has to be able to see what's happening, and then you have to train the model. So we have to train the model to see, is this a kid climbing the fence, or is this an animal climbing the fence, or just a complete false alarm and there's nothing? So back to my pool example, this is a pool that I worked at in Maryland, and you can see by the shadows in this aerial photography that there is a fence around the pool. So that's one way that we can use computer vision. Remember me saying that there are codes many places? So let's say we have a database of all the pools in the county and whether or not there's a fence and the fence height. But maybe we have this, this is structured data now we're looking at. And maybe we have some of these where the data are missing. And we might call out these daycares where there's no fence around the pool. We could combine not just this data, but add to this data set that's structured our computer vision data. And in this case, we could use aerial photography. So I've told you that computer vision, one of the big uses is security and surveillance. Other computer vision uses, interpreting satellite and imagery and aerial photography to look, for example, at land use or agriculture. Or another completely different one is clothing categorization. So you might be looking at clothing to see, is it, a gown? Is it a hat? Monitoring land use changes over time. You can do this. This is a big issue in Maryland where we have too much impermeable surface in the Bay watershed, allowing nutrients to quickly run into the bay and create, dead zones. So land use is a big thing also for planning, for city planners. Another use is biomedical imaging, where you can look at cells, for example, and try to determine if they're cancerous or other anomalous cells. So I've talked about some of the uses, but how does a computer actually see an image? So a computer sees an image as a bunch of pixels. So it's just numbers. Computers just see numbers. These are two of my colleagues. So when you have a bunch of pixels, the computer just sees each pixel as a set of numbers. So if the picture's in color, it will have three numbers: the R, the G, the B, the red, green, blue. A simpler way is looking at an image in grayscale, so I'll use that for my next example. So here it's just a single number from 0 to 255, and you can see how a computer can just look at these numbers and can find an edge, for example. See here how the numbers abruptly change? That is one way that a computer could calculate the differences from one cell to the next. And we have many SAS resources to let you learn more about convolutional neural networks and how they work. But some of the computer vision tasks that SAS can do include things like semantic segmentation, where it's no objects, just pixels, and classification and localization, where there's finding a single object, or object detection, where you're detecting multiple objects, and then instance segmentation, where you have multiple objects and you're looking at them pixel by pixel. So AI or computer vision would be able to look at use semantic segmentation to determine, is this a toy or a PFD? And it decides this is a human and this is really a toy. Do not rely on this for the safety of your child. It's a toy, and if your child can't swim, you should be directly next to them or some other adult or responsible older child. So, can you tell the difference between an official personal flotation device or lifesaver and a toy? Which of these will be certain to save your child's life? So, an official personal flotation device will hold your child in the water and also keep their head face up. So, let's see if you're as good as semantic segmentation. So, these ones here will keep your child, even a baby, even an infant, with face up out of the water. So that's what you want to use. In summary, there was a very happy ending with my brother and sister. This is when they were older and they knew how to swim. I remind my brother, maybe not monthly, but at least annually, that I saved his life. And he grew up to be a wonderful person and has now his own daughter that he puts in a PFD. Remember, if your kids are in a floaty device, you want to be right next to them like this lady is with her daughter. I'm Beth Ebersole from SAS. I hope this was helpful.